We know there's restrictions on the factoring and the square root property method. So let's see what this example here is saying. We've got Imogene wants to make an open top box for packing baked goods by cutting equal squares from each corner of an 11-inch by 14-inch piece of cardboard. She figures that for versatility, the area of the bottom must be 80 square inches. What size square should be cut from each corner? So obviously the idea is you have this rectangular piece of cardboard and you want to make it into a packaged box for, what was it, baked goods? And so we're cutting these little corners out from our edge of the cardboard, and we're trying to figure out what those sizes for the square should be. So obviously we are leaning back on some information that we know. Some information is given to us here in the problem. What are you kind of thinking? Where should we begin with our example? Okay.
Trying to find the length of the distance pretty much of x right there.
Yes.
So just subtract 14 minus 11 and divide it by
14
2.
minus 11?
Yeah.
Okay, and divide by?
2.
By 2. So that would give me 14 minus 11 would be 3. 3 divided by 2. 1.5, right? Does that sound reasonable? Well, no, right? Because it's going to be close enough to that answer, but it's not going to be exactly that answer. So again, the idea is, and I'm going to try and see if it'll let me do this. So if this is my piece of cardboard, and if basically these are the corners that I want to cut off. Right? That means this is going to be the base of our cardboard here. And what did they tell us about the base of our bottom here? For the area of the bottom? 80 square inches, right? They're telling us that right over here. So if that's going to be 80 square inches, we know originally the cardboard has a length of 14 inches. That was weird. A width of 11 inches. How do you think we can come up with our equation?
Right, so 14 minus 2x.
Okay, so where are we getting that from? Yeah, because we know the measurement of these little corners is going to be x by x, basically because these are squares. So if you think about removing those corners once we cut off our corners, right? That's going to be a length of 14 inches minus this little length here for x and this little length here for x, right? So you're going to end up getting 14 minus 2x, and that's the same thing that's going to happen on our width for this cardboard. So you're going to have 11 inches, and then we're going to be subtracting this x and this x here to remove them from our sides. All right, so let's see what this will end up looking like. We will have 14 minus 2x for the length. We will have 11 minus 2x for the width, and what does that tell us? What rule, what formula do I have to use to be able to solve this example? We know it's a rectangle. Yes?
Well, you use FOIL and then get a quadratic equation and then use the quadratic formula from there.
Yes, But what are we setting it equal to? Because right now I just have an expression, right? I don't have anything. I just have my two lengths. So what information are we falling back on?
Oh, the 80 square inches, right? Like we set it equal to that.
Yeah, very nice. So what's going to happen here is when you actually remove these corners, you are going to have what the area of the bottom of our box is going to be. So yeah, you're going to do length times width as the area of our rectangle here. So this will equal 80 square inches, and then we'll do FOIL, right? So what's the result of FOIL going to be? So what is 14 times 11? Sorry?
154.
154, very good. And then you're going to do 14 times negative 2x, which will give us
Negative 22.
14 times
Oh, 14. Oh, sorry. Negative 28.
negative 28x, very good. And then you're again dumbing inside. That's going to be negative 2x times 11, which is your negative 22. And what will be negative 2x times negative 2x? 4x squared. Positive 4x squared. Clean up your left-hand side, combine like terms, and then what else should we do?
4x squared minus 50x plus 154 equals 80.
What was our middle term?
4x squared negative 50x.
Yeah, negative 50x. You're combining negative 28 with negative 22. Negative 50x plus 4x squared. And you're just putting it in order, and I'll do that here in a minute. But what else should I do at this stage? Other way, actually bring the 80 to this side because we want to get our quadratic equation on one side. So we're actually going to subtract 80 and bring it over with the 154, get 0 on that right-hand side. And I am actually going to clean this up. And I'm actually going to bring my 4x squared to the front, minus 50x in the middle. And what's 154 minus 80? 74. 74. And that'll be a positive 74. Just kind of putting it in order of the standard form. Okay, so you have your quadratic equation now. Now it's up to you what method you want to use. So this is kind of open. Obviously, like I told you before, you can use a quadratic formula. You can try factoring, though it's probably going to be trial and error at this point, right? Just working with these numbers. And of course, there's completing the square. So it's just whichever one you're comfortable with. What are you guys thinking? Which method do you like to use? You want to do the quadratic formula? Yeah? Now, just as a note, in all of these terms, do you see anything that's common between the 4, the 50, and the 74? 2. So you do have the option of reducing your entire equation by 2 if you want to work with smaller numbers. If you don't want to mess around with that, obviously your quadratic equation will work. Your quadratic formula will work either way. So if you don't want to reduce it, you can go directly. Of course, this will become our A term. Negative 50 will be B. Positive 74 will be C. So if you want to use the quadratic formula, okay. So remember, you've got negative B from the quadratic formula and then negative coming from the 50 itself. So you should have 2 negative signs. All right, plus or minus. We've got negative 50 squared minus 4 times A. A in this case is going to be 4. I don't know why it's doing that flashing thing. Let's clean this up and let me see what you guys come up with. You ready?
One of these you should take out 2 from the first region.
If you did reduce it? Okay, so that will actually end up giving you, if you reduce this guy, which will be 2x squared. What's 50 divided by 2? 25x. 74 divided by 2? 37. I thought you said 97. All right, and of course 0 divided by 2 will be 0. So if you reduce, you're just working with smaller numbers. What is negative 50 squared?
2,500.
Yeah, 2,500. I guess technically I didn't need parentheses there. 4 times 4 times 74. Or 16 times 74.
1,184.
1184. And then of course we will have 8 on the bottom. So 2,500 minus 1184. $13.16. And if I remember correctly, I don't think you're going to get a nice clean answer when you take the square root of 1316. So what we're going to do at this point is actually use our calculator to get decimal approximations and maybe round it to 2 decimal places. Now because of the plus and the minus, you will get 2 answers. So one of them you will do 50 plus the square root of 1316 divided by 8, and for the other one, of course, just change that to a minus. So 50 minus the square root of 1316 divided by 8, and what will those 2 answers come out to be? And then we're going to have to decide out of the 2 answers which one actually works for our particular example.
Oh boy.
So 50 plus square root of 1316 divided by 8. What does that come out to be? You guys got to start bringing calculators to class if you are not, because it's not about me doing the math, it's about you doing the math. What'd you get?
No, I don't think I know how to use it correctly.
Okay, what did you do?
50 plus square root of 1316.
Okay, hit enter.
Oh, I have to enter first.
Yeah, because your division is going under the square.
Oh, that's.
So what's the one with the positive? 50 plus. Nope.
I did the Lily.
Okay.
50 plus square root.
Yes.
10.79.
Yeah. You're gonna get 10.79, and when we do 50 minus the square root of 1316, so it's round to 2 decimal places, what do we get? Yeah. 1.72 when you round it to 2 decimal places. Now, of course, this is in terms of inches. So out of the two answers, which one makes more sense? So let's go back to our example here. So we got two answers, 10.78, right, and 1.72. Out of those two, which one makes sense for our x? 1.72, right? Because if I take 10.78, which itself rounded is 11, I don't have an edge left anymore, right? Because that's just one x, and I am supposed to subtract x from two different corners, right? So obviously you cannot go with the larger number, so this tells me our approximate value, and you can again do 1 decimal place, 2 decimal place, depending on what my math lab would have as a rounding rule. But just for our sake, we went ahead and did 2 decimal places. So this one here would be a more reasonable answer, and we would actually end up discarding that larger value because it does not satisfy our equation. So honestly, as far as solving the quadratic formula goes, I think you guys should be okay. The main part was, of course, coming up with that equation for your example. So Jose, what you kind of said at the beginning, you were coming up with 1.5. So we were close enough, but obviously it's going to be a little bit different. Any questions on number 13 here? Okay, let's see what that next example is talking about. So this one is an experimental electric solar car. Completed 1,000-mile race in 35 hours. They're saying for the first 600 miles traveled during the daylight, the car averaged 20 miles per hour, more than it did for the 400 miles traveled at night. So basically in daytime it was driving a little bit faster, right, by 20 miles per hour faster than the nighttime speed. They want to know what was that average speed during the daytime. So think about this for a minute. What kind of information can we use from here, and what kind of known information should we have to be able to move forward with this example? In the previous example, we used the area of a rectangle, right, to come up with our equation. What will we need for this example? Ready?
I'm not sure exactly the formula, but would you have something like 600 miles times 20x, and then you've got like 400 miles. Oh wait, no, that's not, I'm getting a little bit mixed up, but
Okay.
like,
I mean, you're definitely going to need to use the distance and the speed here. So what are we thinking? What kind of formula do I need to use here?
Distance formula.
Yeah, you actually need the distance, rate, and time formula here. So that's our, dirt formula. Distance equals rate times time. But obviously we'll need to figure out how to rearrange it based on this example. So let's actually go ahead and break this down into what information we have on hand. And right now, let's see, we've got our distance, rate, and time. We've got daytime and nighttime, right? They're telling us we're driving 600 miles in the daytime, 400 at night. What else are they telling us?
Is the time 35 hours for both of them, or how would you know?
So that's the total time it took them to complete 1,000 miles. Yeah, so that's your total for the time. What are they telling us about the speed of this solar electric car?
So the speed is 20 miles per hour more in the daytime. So
Yeah.
I'm assuming it would be something like in the daytime it would be X plus 20, and then for the night it's just X.
Yeah, so it actually depends on how you define your variable. So are we defining X for the daytime or nighttime? I would actually prefer using X for the daytime because that's the value we're trying to find. But if you were using X for nighttime, then we know you're going 20 miles faster during the daytime, so we would add the 20 in the daytime hours. But like I said, I actually prefer using the unknown for the direct quantity that they want us to find, which means if I am driving at a speed of whatever, which is going to be 20 miles faster in the daytime, nighttime will then actually become X minus 20, right? Because you'll be slower. Now, the way we're actually going to set up this equation is going to start out looking a little bit different, but when we clean it up, you will see where that quadratic is coming from. You will need to rearrange your distance formula for time, which means we will have distance over rate equals time, because we know together it should take them 35 hours to get this journey completed. So when I set this last column up, it's actually going to be distance over time. So that's going to be 600 divided by X for the daytime hours. And then it's going to be 400 divided by X minus 20 for the nighttime hours. And let me actually go back here. So we've got 600 over X for how many hours we'll be driving in the daytime. We're going to add that with the nighttime hours, which comes out to be 400 over X minus 20. And we know together the total journey took 35 hours. So that's where our initial setup is actually going to come from. So what do you think our first step should be in solving this equation?
Common denominator.
Yeah, least common denominator. So what do we think our least common denominator should be? Obviously when there's no denominator, make it a 1. So between X minus 20, and 1, what will our least common denominator be?
X in parentheses, X minus 20.
Yeah, so you actually just multiply all the denominators together, which will be X times X minus 20 and 1, obviously. Now, keep in mind, when we had done a similar example like this in the beginning of chapter 1, I had talked about how I like to get rid of my denominator so that way I'm not messing around with fractions anymore. I'm actually going to use that same concept here. So that means every one of these terms is going to be multiplied with our least common denominator. So I'm going to multiply all my terms with the least common denominator. So what will happen when we multiply? I'm going to try and write this so I can squeeze everything in here. What do you think is going to happen with our denominators? Start canceling out. So on the first expression, the X will cancel out with the X from our least common denominator, leaving us behind with 600 times the parentheses X minus 20. So what do you think will cancel out in our second fraction?
The x minus 20.
The x minus 20, very good. So x minus 20 cancels out, leaving us technically with just 400 times x, or 400x. Does anything cancel out on the right-hand side? No, because I don't really have a denominator there, right? So you're basically just going to multiply 35x with x minus 20. Okay. And you can see when I multiply this is where my quadratic x squared will come from. So let's go ahead and multiply these guys out. Of course, we'll need to distribute these. So that will give us 600x minus, what is 600 times 20? 12,000. So 6 times 2 is 12, and then you've got 3 zeros, right, to follow along. Plus the 400x. And of course, here we're going to be doing 35x with x. And that will give us 35x squared minus, what is 35x with 20? Yeah, 35 times 2 is 70. Slap on that extra 0. And don't forget your x. Let's clean everything up. Let's bring everything to one side so that we do have that quadratic equation. So since on the right-hand side, I have my 35x squared. If you want to keep it positive, then move everything to the right-hand side. If you don't care about making it negative, you can move those terms to the left-hand side. It's really not going to make a difference. So I like my leading term to be positive, so I think I'm going to move everything to the right. But the first thing I'm actually going to do is go ahead and combine these like terms. I've got 600x and 400x, which will of course add up to 1000x. 1000x minus the 12,000 equals 35x squared minus 700x. So we'll start by subtracting the 1000x. These guys will cancel out. We can add our 12,000. Those will cancel out, giving us 0 equals 35x squared. What happens with my 700 and 1000?
Negative.
Yeah, negative, because both of them have negative signs on them. Negative 1700x plus 12,000. That is not a pretty looking equation, is it? You got a question there? Charlie, you're looking a little.
Did you scroll up like just a little bit?
Yeah.
Okay.
What happened?
I found it.
You got an X. Don't forget an X. Okay. Question so far? Because again, remember, this is the important part of coming up with your equation, getting a quadratic, and then after that, it's just about solving that quadratic. So we started out by using our distance, rate, and time, which gave us our basic equation 600x, 600 over x, plus the 400 over x minus 20, because you were 20 miles slower at the nighttime speed. And together, that added up to a total of 35 hours of our driving time. Using the LCD of x times x minus 20, we got rid of our fractions, and then basically we just cleaned up our equation, right? Now again, you have the option of reducing your equation if you want to. I'd probably start with the 5 and see what happens, but if you don't, obviously you can go into which method would you use again to solve this. So how can we find our x at this point? would probably go with the quadratic formula, because factoring again would be pretty trial and error at this point, trying to figure out, what numbers would work. Did you want to make these into smaller numbers or not? Or you just want to leave them as they are? Leave them? Make them smaller? Yeah? Okay. So if you want to make them smaller, you are dividing everything by 5. Now, can anybody tell me why I picked 5 as the number to reduce by? Those of who are in the lab, you should be able to answer that.
They either end in 5 or 0.
Yeah, because all my numbers are either ending in a 5 or 0, so that tells me 5 will go into everything. So of course 0 divided by 5 is 0, 35 divided by 5? 7. 1700 divided by 5?
340.
340? So that would be negative 340x. And that can come out 12,000 divided by 5. 220?
400.
2400.
2400? Did you say something else?
Yes, that's like the next one.
Oh, that's the next.
Yeah.
Okay. Alrighty. So not too bad, but obviously there's still going to be larger numbers. I guess just not as bad as where we were at. This is your A, B, and of course our C values. So that would be x equals negative b plus or minus b squared minus 4ac, and the whole thing over 2a, which will give us, and again your b has a negative, which means you should have 2 negatives at the beginning, negative and then negative 340, plus or minus, under our square root we will have negative 340 squared minus 4 times a, which is 7, c, which is 2400, the whole thing divided by 2 times 7. Right, let's clean it up. Let's see what we end up getting. So you are doing negative 340 squared, so the negative and negative will become positive. What is 340 squared?
115,600.
Yep, it's going to be a pretty large number. Very good. 4 times 7 times 2400.
$67,200.
Yeah, all right. 67,200, which will give us 340 plus or minus whatever that subtraction comes out to be. And of course, your denominator 2 times 7 will become 14. Is 48,400 a perfect square?
Yes.
Yeah, what do we get?
220.
220? Okay. So that would make it 340 plus or minus 220 divided by 14. And then again, you can break it up into 2 parts. 340 plus 220 over 14, or 340 minus 220 over 14, and what will those guys be?
Forty.
40 for the plus? Or
8.57.
decimal?
Yeah.
Huh. Did not see that one coming. What is this? Time? Miles?
Okay. The rate.
The rate, right? Because that's what we set our x to be, which was the speed during daytime. So that is in miles per hour. So out of the two, which seems to be a reasonable daytime speed? 8.57, because that's a terrible car. Don't put it in the market. Obviously, it's got to be 40 miles per hour, right? Now, if you had set x as your nighttime, what extra step would we need to take? And I guess that's mainly for you. What would you have to do?
You'd have to add 20 to your,
Yeah, so if you had set x as your nighttime speed, then your daytime speed would have been x plus 20. So the answer you got, you would then need to add 20 to that, which technically means you would have got 20 as your answer. So it really makes a difference where you set your unknown quantity as. Since we set x directly as our daytime speed, you don't have to do anything. That's your 40 miles per hour. And so we are looking at that as directly our answer. Any questions on our number 14 here? Okay.